I started thinking, well, let's do another hot rod. Well, what would the ultimate hot rod be?
It's a lot different car than most roadsters. When everybody sees it, they're going to say, well, wow.
The way the car is being built and assembled, we're truly using modern and innovative technology.
It's every bit that Offenhauser in that configuration. I mean, it models American hot rodding. You're taking something and you're making it in a different form. You couldn't pick a better engine.
What I love about the Martin car project is that it's this blending of old and new.
My name is David Martin, David Charles Martin. Getting into this, I think what's important is I grew up in an architectural family. I'm third generation of 3 generations of architects. And I learned very early that if you have an idea in your head about something imaginary, and you can have that idea become a reality. You know, I started off with these little clay models and picture drawings, trying to get three-dimensionally what I had in mind. We worked with a great guy, Eric Park, out of Art Center. We were able to put everything to scale, and he was able to use programs to start to refine this body.
Stamping out the section of a car body. Everywhere about the plant are interesting mechanical scenes.
The idea of building this traditional hot rod, but taking traditional ideas of fabrication of steel and using computer programming and 3D printing and all these technologies. So here the architecture and the ideas of the car come back together. My niece Holly, she knew through her photography at Bonneville, and she knew a lot of the fraternity of hot rodders. And she introduced me to Biggie Steve Watt. You know, what a great name.
To have the fastest car in the world sitting here. I mean, there's one car that's the fastest car in the world, and this is it. And it was all built here. Well, my name's Steve Watt, and I'm the president of Maxwell Industries, which is a company I started back in like '99. Like, I've been fabricating most all my life, and just, I want to say I was 5 years old. My dad was a tool and die maker, so he was in machine shops and shops all his life. And when I was 5, he had a guy work for him named Ernie Rose who raced super modifieds, and he would take us and all the kids in the trailer park. We'd get in the station wagon and go to the racetrack and watch on Saturday night. Once you go and you hear the noise and the smell and feel the cars go by, I mean, it was like, that's kind of how it ended up, and there was no chance of me doing anything else. We've been building, like when I built this car, we started this program where we build these wood bucks that has a center line in it. And every time I put the car back and forth on the jig, and if anybody builds cars, you're always constantly measuring center line, center line, center line. We're trying everything in the world to use the newer technology to build stuff quicker, faster, computer design stuff, and still keep it old. It's kind of an exercise in taking the next level of how things get built. One of the first things we started on was brakes. So we were at Schroeder's and we did, we wanted the lobster style brakes. So Schroeder said, yeah, no, that ain't gonna work. So you gotta figure out what you're gonna do. So he gave me a caliper and said, hey, figure it out. You gotta make something that works. So I went to Willwood, we designed a caliper, and now fitting that caliper on, because Dave wanted wire wheels and mag wheels. So the fitment, we had our parameters set for the performance of how we wanted the car to drive and handle. So we didn't want to sacrifice that, but doing that, having the wire wheels with the brakes and the spindles and all the stuff we have, fitting it in is become quite a challenge. A big thing today, like motor placement, is key in the handling of a car. And we've gotten the motor back and back and back, and now we got the pedals where we wanted them. Dave's sitting in the car where he needs to be. So now we can get the motor back right up against to where we have enough room for the pedals, and that's the best optimum spot for the motor as far back as we can get it.
So the idea of doing the first sketch almost conceptual thinking in one program and then taking that database and putting it into a more technical program. That's where Channing came in.
There's a letter of reference to Claude Ryan, who was Ryan Aircraft. They were the guys that built the Spirit of St. Louis. And Earl Ovington's considered one of the very first airmail pilots in the United States. And then he actually taught my grandfather how to fly. And this is a letter of recommendation to Claude Ryan to hire my grandfather to go to work. That's incredible.
This is Spartan,
Oh, okay.
and this is in Tulsa.
Tulsa, Oklahoma?
Yeah. And this is Dad. He's right in the picture.
Okay.
And he was a lead engineer, and these are all his engineers.
What an amazing picture.
I know. And I mean, those guys were aeronautical engineers.
Yeah.
And he was their leader, and he didn't even have an aeronautical engineering degree. He had
At that time, oh, he had an electrical engineering.
electrical engineering degree. But because of his efforts that he did at Ryan.
This is after Ryan.
Yeah, this is after Ryan. So yeah, that's a pretty neat. And look at these guys are all using drafting tables and slide rules. And
My name is Channing Hammond, and I am one of the computer designers on the Martin Indy Special. Well, my involvement in the program came through Steve at Maxwell. It was really because I was there involved in a previous race car project, a Bonneville salt flat car that we built and completed. And while we were working on that, we got the opportunity to start investigating how we were going to build the Martin car. The real impetus for the computer design came from my early involvement with my family's race cars. In about 2000, I had a friend who was a SolidWorks salesman, and he gave me a pirated SolidWorks copy. And that was my first foray into computer design. And growing up in a metal fabrication shop and growing up with my dad, and I've just always wanted to come down here and be a race car guy and just a fabricator in general.
that one picture of the sedan on that side.
This one right here?
Yeah,
that's in front of Santa Barbara High?
Yeah.
Yeah.
I had that car in high school. You know, people say, how'd you get interested in hot rodding? I clearly remember riding my bike to the El Camino pharmacy, which was right across from the Montecito Inn, and buying Hot Rod magazine.
Yeah.
And I was like 10.
Yeah. And then Gray Baskerville would come and hang out with you at Bonneville.
Yeah, that was much later though.
Yeah. When I finally got an opportunity to really see what SolidWorks could do, it really sort of changed my world, and I really just dove into it. I mean, in terms of inspiration here, this whole place where we're at is inspiration for me. And my father has so many amazing vintage parts and gauges and rear end housings and all of this stuff. And so basically everything here is an inspiration. Even if it's not the same part as you're working on. I mean, I've been staring at a lot of this stuff behind me for all of my life. And so that's very much why I wanted to do this this interview here, is because this whole place is inspiration that I bring to the project. In terms of chassis design and suspension design and things like that, we really have a wide open slate to work. And so that's, in some ways, has created a challenge. That's also where the computer gets to come in, is because we have an opportunity to try different things and kind of go out in different directions. So what we're doing is we're using some sprint car technology where we're using a splined spindles for the front and back axles. And because one of the criteria was we're going to be running wire wheels and mag performance wheels, we wanted to be able to change them quickly using a knockoff style axle nut. So we basically started with this spline spindle right here. We've been working with Dayton wire wheel, and we developed a hub that this will ultimately be drilled and laced into a rim to become a wire wheel. So we had to get the spacing of this and the geometry right for the correct spoke angles. And so that's basically, along with the sort of steering axis inclination and the scrub of the tires, we had to start here and then basically work backwards with the whole front end concept. So that is why that actually led us to a pretty unique A-arm connection and solution with our spindle here. And ultimately, in this front end, the lower A-arm is going to be about even with the axle, and then the upper A-arm will be above and then drop down. And so it's possible that in the end, we're going to make this thing look so sleek that you might actually think it was a straight front axle, but it is going to be an independent suspension. Dave has actually been really welcoming to ideas that we've brought to the table. And he obviously, like I was saying, he is able to articulate a vision that he has for this. But at the same time, it's almost like having a blank sheet of paper sometimes, because we have this opportunity to sort of create something out of nothing. We're not trying to make a 32 Roadster. Yes, we're looking at the Indy Roadsters of the day, and we're trying to come up with something that is an homage to that era of Indy race cars.
This incredible dichotomy, you know, at one end you have this idea of building something traditional. Well, you use traditional tools and all of that, traditional parts. And the other idea of let's do something that nobody's ever done before. Let's try to take the new technology and push it in some way.
My name is Cully Millage. I'm from Sioux Falls, South Dakota, born and raised. My background is in fabrication primarily, CAD modeling, and a lot of racing and motorsport. Just to revert back, I was always super drawn towards building stuff and making stuff and art and Legos and all those things, right? When you're a kid, I was all in on all of it. So it was very obvious early on what I was going to be drawn to.
This isn't anything that you can kind of just set the machine and do. It's kind of an art thing where you have to kind of get a feel for how much it's bending, for how much you, like 0.2 or 0.4, how much it bends a piece of 95 compared to a piece of 120. So you really got to gauge it, and just you get a feel for. Kelly's caught on really quick. He does it really well. I mean, I just stand back, let him do it now. We started on the first one and he had it figured out in 10 minutes, so I just.
You know, moving forward, I got into riding motorcycles and stuff, so then we started racing, and I started racing when I was maybe 12 or 13, and it got pretty serious for a while in high school, and I got a professional license. You know, that was a big deal, and I was able to meet a lot of people in the motorsports field and, you know, top riders and teams and stuff, and that's kind of how things snowballed. I ended up gravitating towards the fabrication side, but I made my connections from like the racing side, so I just kind of collided the two, and that was the direction I headed. I'm 31 now, and for the majority of my adult life, and before that, I was fabricating and building stuff, and it was heavily in the exhaust side. So I have a small exhaust company that I build a lot for race teams and stuff, and that's really how I made this connection to Steve and Maxwell, was through the exhaust side and the flat track racing team that he has. A number of things have kind of transpired the last week or so, but we kind of see proportionally what the car is going to look like. Stout in this area and gets smaller and narrower as we go towards the front, but this rear hoop section turned out really nice. It kind of finishes the backside of the chassis, so we're all really happy about that. It's kind of a constant radius from the bottom of the frame rails, hoops back from the tail of the car, so it gives it a good aesthetic, but also structural integrity.
It's the first time we've really seen the car in a three-dimensional manner. We've seen the two-dimensional drawings, we've seen this quarter scale model, but now to see the tubes in place, you're starting to visualize the reality of this whole crazy dream. And to me, it's very, very exciting.
So the 3D printing processes are extremely powerful in manufacturing today, and I use it as much as I possibly can. We have little affordable printers right here at the shop. So for small parts that are little like 10 by 10 by 10 or 12 by 12, we can print it right at the shop, and in a couple hours you're holding it in your hand. So there will be a ton of 3D printing done on this car before the part goes to final manufacturing. Actually, it's funny that we're filming this today because this part actually showed up today. We just got this part, so we're all excited about it. I'm super stoked about it because I'm kind of thinking back about some of the stress that was involved in getting this part to machining, you know, and winding back the clock a little bit. This is the original blower plenum that was on the Offie engine. So we actually take this design and the functionality of this part, but compact it down into a sort of a condensed, functional, but beautiful part. It wears multiple hats. Number one, it houses all of the injectors. So there's 4 injectors in here. That sort of slip into the bottom and then also will slip into the top side of the plenum. It will also house the electronics for the injectors through there. I guess with that being said, this is the Martin Indy quick change rear end. So moving forward from the model, just like the blower plenum, when everybody was on board and said, yep, this is a good design, we went ahead and 3D printed it. And if we shift over here, we can actually see the rear end completely 3D printed to a scale model, which was a lot of fun to receive this in the mail, I'll tell you that. So it's certainly the most elaborate component that I've ever 3D printed. So I was thankful to be able to do that and be a part of this.
I said, well, what would the motor be? Well, you know, there's about 5 choices. A flathead is a great traditional engine, or a blown flathead, or an Ardent is really a good choice, small block Chevy. Then I said, well, the ultimate American hot rod engine is the Offenhauser. That's the Indy, the sprint car, everything. That's the ultimate traditional hot rod.
So probably first time in 60 years this has had 4 new pistons in it. My name's Chris Trammell. I'm currently building the Martin Indy Special Roadster supercharged Offenhauser engine. So I've been building engines professionally for 15 years for a couple different companies, one being Speedway Engine Development, and my current full-time job right now is for Ed Pink Racing Engines. And now I've started my own business, working over at Maxwell Industries under CT Enterprises. We're here at Ventura Raceway, and this is a special place to me because this was my introduction to motorsports and high-performance engineering. Came to my first race here when I was probably 9 years old. We sat in the dirt over there, and then, you know, circle back when I was 13 years old, I started working on a sprint car out here. About a 6-year racing career here. Ran stock cars, figure 8, sprint cars, modifieds. We won in all those disciplines, so that was really cool to be here, and it really just evolved me into the engineering side of things. I was really thinking I was going to go the IndyCar route, and finally just got tired of being on the road after 6 years and living out of hotels every now and then and doing 70 events a year that you got to do track support, then doing 100-hour weeks at the shop, you know, to get somebody else his race car ready. And then when I came back out here, I started doing a lot of different kind of engines, everything from World War I to the current hypercars out there. Around about 15 years later, after I'm not driving that much anymore, I get to be involved in that project with Steve Watt, Dave Martin, Channing, and Cully, and just a group of guys that have the passion. The biggest one, the one I've always wanted to do, was Offenhauser. And so have that opportunity, and so I think of it like my Mona Lisa. So I hope it's that good, and I hope it lives up to those expectations.
in the grass doing work.
We're a little cleaner than that. It's just a good joke, and I thought about everybody as you start building high horsepower stuff, and it's not rocket science. It's more like being a chef than it is being a scientist. There comes into play the Mexican food joke. Engines are all the same, it's just how you stack them. This one was one of 17, and it never really went too far. It wasn't that popular, so it wasn't really done too much. I mean, the supercharger wasn't the most efficient, it wasn't driven in the most efficient way, but I think technology just kind of passed it by, and they came up with better stuff for racing, and so it's the first one I get to do start to finish is one of the rarest ones you can find. Originally, this engine was equipped with a Joe Hunt magneto, and so that would sit right up here, and it's driven off one of the idler gears at half speed, off a bevel gear, so it keeps the timing correct. So we've decided, because we needed to put a cam sync in here and a coil pack, that we're going to take the bottom half of that magneto, and we're essentially just going to hollow it out, and we're going to put our coils in there, we're going to put our cam sync in there, and so it stays true to the Offenhauser look with the magneto on the front, but we're going to put our little spin on it. So this would be our proof of concept right here. Coley's been working pretty hard on it to get where we can get everything, because we're going to have a little magnet right here, and that's going to come down to the cam sensor. That's going to come right up here, underslung from the bottom, so it's out of sight. And so every time this passes, it'll pass that magnet, it'll pick up a hole there, it'll tell it to fire the injectors. So we went to the fly-by-wires so we can control the rate that the butterflies open. We can control the pitch, because being an old Speedway race engine, it's got quite a big butterfly on it. And so we wanted to control the rate of it so you didn't pull a whole lot of vacuum, you know, try to make it nice for a Sunday cruise, you know.
I often think to myself, why are we doing all this? This is crazy stuff. What's the payoff? You know, it's not as if we could win the race. Maybe we would create a beautiful car, and everybody loves a beautiful car, put it in a car show. We're doing this, I suppose, as I hate to say it, it's almost an artistic exercise. It's an exercise in exploring how far you can go with the technology and the machinery that we've got.
They are attached in a rubber insulated ball socket. By the use of the rubber insulator here in the socket, a new element of quietness is introduced. Metal-to-metal contact is eliminated, and lubrication is unnecessary. In this car, we find the rear spring mounted back of the rear axle housing, a low, flat spring with full flexibility. Rear springs are made in several sizes to meet the riding requirements of the various body types.
Last few weeks have been a real push. We're trying to get the chassis ready for the Art Center exhibition, and we're going to be showing the rolling chassis with all the suspension parts, engine, the bell housing we've designed. It's going to be sitting on the ground under its own spring rate, and so it's a pretty exciting moment.
We're out here at the Art Center in Pasadena, and we're showing the Martin Special Indy Roadster for the first time as a rolling chassis. This is the first time we've all seen it on the wheels and tires, so it's a big and exciting day for the whole team. This has been a long process to get to this point, and the whole team has worked really hard. As far as what people are going to make of the project, you know, there's going to be unique responses, I'm sure. I hope that it's mostly positive. I know what we were going for in terms of the era of an Indy Roadster specifically, and I think everybody on the team feels that we have met the objective and the target was hit, so we feel good about it, and I hope that the response from everybody else is positive as well.
To get a car off the buck and put the engine in and have it sit on all its own suspension for the first time, and really see the car take shape. I think it's going to be a good response. I think a lot of people are going to have questions about where the old, like the old engine meets the new, and just where the art side of stuff comes in and where all the creative processes came in to mend a new chassis to an old engine with some new parts, and how we integrated all that, trying to be seamless.
I did not have any expectation for this event because I was too busy worried about actually getting here. So I'm just amazed at all the different vehicles. And I love the fact that we were able to come here with just a bare chassis and show off all the parts underneath that we've worked so hard to produce. So, so it's exciting to see it actually just the chassis here. I think that's kind of unique actually. And all of a sudden Dave's sort of vision for us coming here really makes sense, I think. We've been working on it on a table. And so to finally, it's always a special moment when you take a car that you've been working on 3 feet off the ground and put it on the ground, and all of a sudden the angles and the perspective and everything changes. And so I think that's been the interesting conversations, is all of us standing around and seeing how low the engine really is and how low the car is in general. So that's been a fun seeing this milestone.
I'm kind of at loss for words. It's like it's something you never experienced before. So as you're talking to people and they're asking questions, it all revolves around pretty much the art design of what and why and how come you're doing what you're doing, which really makes a lot of sense coming from a design school, art school. The interest was amazing on Dave's car. Couldn't be more happy with the results of how it looks and how it was represented here at the school. And we were welcomed like they really, really enjoyed not having a body on it, seeing all the mechanics of the car and seeing how things worked.
My personality and what I wanted to do is I wanted to be in the game. I wanted to play the game. And what we found out is if we played the game and we were having fun, every once in a while we'd win. Not every race, not every show, and it's that process, the creative process. This has been very enjoyable to me.